Hey, this is Mr. Sarkany, and we're learning about covalent bonding in molecular compounds, which are often found in explosives. Let's take a look. So there's three types of chemical bonds, and a very simple way of determining them. If you're going to have an ionic bond, that's between a metal and a nonmetal. So ionic is a metal and nonmetal. Covalent is between two different or the same nonmetals. Only nonmetals for covalent. So you could have a nonpolar covalent bond or a polar covalent bond. We're going to try to simplify this in a very easy way. If we have two different nonmetals, we're going to consider that to be polar. Two different makes it polar. That's our simplification. Covalent bonds share electrons. So if it's the same, it's nonpolar. If it's different, it's polar. Now, when we're thinking about this, we need to determine which one is going to be more electronegative. Fluorine is the most electronegative element. As you go away from fluorine, the electronegativity decreases. So as we see in this polar covalent bond, the closer it is to fluorine, the element is going to get the partial negative. Closer it is to fluorine, the more likely it's going to be partial negative. Further from fluorine is going to get the partial positive. So hydrogen's way over here, further on the left side of the periodic table, so it's going to get the positive. So the closer it is to fluorine, the negative it gets. Now, how are polar covalent bonds and nonpolar covalent bonds similar? Well, they both have nonmetals, right? They both have nonmetals, and they both share electrons here. So these are shared electrons. The ones around the different elements are unshared pairs. Unshared pairs. Now, how are they different? Well, polar have different elements bonded, and they have unequal sharing. These are going to be pulled closer to the chlorine, hence why this arrow is kind of thicker or fatter, while in a nonpolar bond, there's equal sharing of electrons, hence why these arrows are dotted the same. So we've identified how to look at different covalent bonds, but how do they even come together? Well, molecular compounds overlap their electron clouds. They share electrons, which makes them covalently bonded. So here's what comes together. The attractive force of one of the nucleus is for the valence electrons of the other atom. This pulls the atoms together, so they start coming together. This happens until the repelling force of the electrons, which are around here, is equal to the attractive force between the nuclei and their electrons. The resulting covalent bonds have a sharing of electrons between the atoms. So this is modeled in this image. This has 4 shared electrons. These are shared electrons, like a Venn diagram, with the X's originally belonging solely to the carbon, while the dots were solely belonging to the hydrogens. And these are Lewis structures, which we'll show in the next area of how these electrons are also formed and shared. Now, this is all about attraction and repulsion. If the repelling force is stronger than the attractive force, then they bounce off each other and do not bond. This happens all the time with all of the molecules in the air that don't react to form something new. Now, the positive thing that's attracting the negative thing is the nucleus attracts the valence electrons of the other atom. This causes the bond to happen. So final thoughts. Why did carbon marry hydrogen? They bonded well from the moment they met. Make sure you answer the question as our final question and come in with any questions you have. See you soon. Take care.